Now Zener diode is another application. As I have already told you, this is the anode end, this is the cathode end. Plus minus Vz is the Zener voltage across which the current will rise exponentially, but the voltage will remain constant. Okay, the Zener off state, Zener on state. Now, how to actually calculate the Zener diode is working or not? Okay, so you can see that if Zener diode is connected in the parallel, then whatever the voltage drop is across the load. Okay, that will be across the Zener diode. If it is less than the Zener diode voltage, then it is open circuit. If it is greater than the Zener diode voltage, then it is short circuit. Okay, giving the maximum voltage across this terminal will be plus Vz. Now this is the formula the theory about which I was telling to you earlier. For Zener diode, yes, we know that the VL, the load resistance the load voltage will be equal to the Zener voltage. That is the confirmed assumption. But what happens that we don't know about the current. The current can vary across the load as well as across the Zener diode. But that depends. But the initial IR current remains constant. Okay. Keeping these things in mind, we have two cases: the fixed and the variable. Now, in the fixed VI case, when the voltage is fixed but the load resistance varies. In that case, we keep VL equals to Vz. Now, earlier we have known that VL is a voltage. If you do a voltage divider thing over the load voltage, you will get voltage into RL divided by R plus RL into Vn. The RL minimum is equals to, if you say that it's a minimum, let's suppose it's given it is a minimum. Okay. Then we have a maximum Imax current and a minimum Zener current. Zener diode current will be minimum, and that minimum current will give you the maximum. The minimum Zener current will give you the maximum load current, and the maximum Zener current will give you the minimum load current. To calculate RL max, the maximum voltage, we have Vz divided by the IL minimum current, which is equals to IR minus IZ minimum. We keep the resistance current constant. Okay. Now the fixed RL and variable RL, same thing, same formula, same, but only the VI is different in this case. Now there are voltage multiplier. This is a doubler and this is tripler. Now if we talk about doubler, then you can see that if there is a positive voltage, then plus Vm. Okay, and this diode will be, D1 diode will be short circuited and there won't be any output voltage. However, when there is a negative voltage applied, then the diode D2 is short circuited and C2 is rise to a potential of minus 2 Vm. This minus 2 Vm, which is double of that voltage, appears with a reverse in its phase at the output. Same goes with the tripler and the quadrupler. Now